Good morning, friends. In today's lecture of design of jig fixtures, we are going to see factors considered for design, fabrication, and assembly of jigs and fixtures. Or in the Y position or in the Z position. So you have to think again that component due to vibrations may come into this position X component can move into Y position and again component can move in Z position. Now if you have got this much of the knowledge related to the block and its movement, let us move further. Now since you have considered the three axial system, that is X, Y, Z, now according to Cartesian coordinate system, always there are two axes. The first axis denotes for positive side, that is x plus, y plus and z plus, and another side denotes for negative reference index, that is x minus, y minus and z minus. That means now you have to consider the block in three positive and three negative directions, but keep in mind that the axes are linear. Therefore the component will move either in x plus direction or x minus direction. The component may move in y plus direction or y minus direction, and component can move in z plus and z minus direction. So you have to think widely that there are 6 linear motions or 6 degrees of freedom available to the component. Dear students, the motions that can cause in the linear motion or movement in the linear axial system will be x plus, x minus, y plus, y minus, and z plus, z minus. So we have understand 6 degrees of freedom. Now we will move forward. There is a possibility that if the hole is to be made on one of the edges of the component, you can see the edge 1 or edge 2, or the component may be at edge 3. There may be some drilling or sharp operation on the edges. Now due to this, the tooling pressure, component may wobble in the x clockwise and x anti-clockwise direction. Component may move in the y clockwise and y anti-clockwise direction, and component may move in the z clockwise and z anti-clockwise direction. Now keep in mind, there is only twisting and turning motions, therefore no need to be positive anti-clockwise or negative anti-clockwise. Anti-clockwise is the 1 degree of freedom and clockwise is the one another degree of freedom. Therefore it has constituted that there are 6 linear motions we have seen: x plus, x minus, y plus, y minus, z plus, z minus. Again there are 6 twisting moments, or we can call 6 twisting degrees of freedom. And what are they? They are x clockwise, x anti-clockwise, y clockwise, y anti-clockwise, and z clockwise, z anti-clockwise. Now my dear friends, it is clear that the component can only move in these 12 degrees or 12 movements. Therefore we will call this as a 12 degrees of freedom picture. Okay. Now if you want to fix up, if you want to set up the same component on the machine table, then you have to take care that out of these 12 degrees of freedom you have to arrest some degrees of freedom. But while doing so, you have to take precaution that all degrees of freedom will not be blocked. Now the condition may arise. Why? This is because the component once set up inside the block, if you want to remove it and put up another component, then at least there should be some degrees of freedom provided. Therefore, out of 12 degrees of freedom, you have to arrest some degrees of freedom, and we will see how it proceeds. I hope up to this you have understand. Moving forward, over here you can see how the component can be placed inside a block. Already we have seen that there are supporting pins which help the component to be securely placed inside the jig or fixture. Now let's understand. These are the 3 views. Typically your top view, front view, and either LHSV or RHSV. These views can help you to understand the positioning of the pins. Now you can see a component has been placed inside the body. There are locating and support pin. Number 1, number 2, and number 3 are the supporting pins. Now you can see the component cannot move towards the body. Why? Because there is support pin number 1. Component cannot move towards the right side of the body. Why? Because there are 2 side pins or 2 locating pins over there. That means component has to move in the away direction. Component cannot come towards jig body. In this view, it is clear that how component is resting or how component has been stopped. We will see. Okay. So in this diagram you can see how it has been rested and how it is resting on the component, and in this diagram you will get a clear idea that how locating pins, how clamping forces, and how supporting pins work together. Now this is the generalized idea related to the clamping of the workpieces. We will see again. Degrees of freedom is defined as number of independent motion a body has. That means already we have seen that there are axes. You can see over here they have given y plus, y minus, x plus, and z plus, z minus. Okay, and again y clockwise, y anti-clockwise, z clockwise, z anti-clockwise, and x clockwise, x anti-clockwise. So now moving to next, principle of clamping of the workpiece. It is a principle of clamping widely used. 3 pins are used at the bottom, therefore they will restrict 4 rotational motions, that is 4 rotational motions associated with the x and y axis, that is x clockwise, x anti-clockwise, y clockwise, and y anti-clockwise. These 4 rotational motions and 1 linear or translational motion associated with minus z directions. You can see over here x clockwise, x anti-clockwise, y clockwise, y anti-clockwise, and z. That means the pin position must be at this position: pin 1, pin 2nd, and pin 3rd. Okay, so the first 3 pins have covered 4 rotational and 1 translation. In all, 5 degrees of freedom have been arrested using 3 pins. Next 2 pins will restrict 2 rotational motions of the z axis, that is z clockwise and z anti-clockwise, and 1 translational motion, that is in the positive x directional. We can see over here z clockwise, z anti-clockwise, and x positive. That means the location of the pin is at this one and this one axis. Okay, moving to our next point. 1 pin, it will restrict 1 translational motion, that is plus y only. Therefore 3 plus 2 plus 1 will combine total 9 motions, and remaining 3 motions are used to set workpiece at a desired location and can be restricted using clamping method. What are the clamping techniques that we are going to see in the next lecture? Now see the diagram and you can understand well what is the 3-2-1 principle. Now you can see 3 different blue colors are indicated to show the pins. Therefore sky blue color indicates 3 pin positions, then mid blue color indicates 1 pin, and dark blue indicates 2 pin. So 3 pins have restricted pin number 1, pin number 2, pin number 3. Then 2 pins over here and 1 pin over here. Now these 3 pins are typically at the bottom, 2 pins are typically on the left side, and 1 pin typically on the right side. When you will combine these 3 figures, you will understand that is 3-2-1 principle over here. Now some basic principles or rules to be followed while planning or locating blanks in the fixture are: 1 or more surfaces, that is machine or drill or boreholes, are to be taken as a reference. The reference surface should be significant and important features based on which most of the dimensions are laid down. Locating should be easy, quick, and accurate. In the case of locating by pin, the pin and their mounting and contact point should be strong, rigid, and hard. A minimum of 3 points must be used to locate a horizontal flat surface. The locating pins should be as far apart as feasible. V-block and cones should be used for self-locating solid and hollow cylindrical jobs. Site location is applicable to first operation location of blank with irregular surfaces produced by casting, forging, etc. When the bracket is first located onto edges to machine the bottom surface, which will be used for subsequent locating. adjustable locating pins is to be used to accommodate limited part size variation. So this is the ideal structure for location using a V block, where a cylindrical surface is having chance of rolling over. Therefore in the bracket of this V zone it can be fixed up, and using a drill or cutting tool the machine can be working accordingly. Dear friends, up till now we have seen 3 to 1 principle, which is of wide importance. It will be asked in the exam, so you have to prepare it thoroughly. Just draw the diagram and make a practice of it. We will continue the same series of lecture. Till then, thank you.